See the concept of error analysis. Here, first I want to define the basic concept, how to define a error. Mainly that error is called, we can define as a static error or absolute error. You can define a static error or it is also called absolute error. Absolute error. A static error or absolute error is denoted by epsilon naught or delta A, is defined as measured value minus true value. Measured value is a fundamental definition minus true value. Measured value minus true value. Now, as a notation, this absolute error or static error, delta A equal to measured value AM minus true value AT. This is the fundamental definition of absolute error or static error, where AM means measured value of quantity A. Measured value of quantity A. Quantity A. What is AT here means true value or value to be measured. Value to be measured. Value to be measured. Or it is also called expected value. Expected value. Expected value. Where delta A or epsilon naught we can define delta A. Absolute error or static error of quantity A in the measurement of quantity A. We can give delta A means in the measurement of quantity A how much absolute error is present. We can define delta R. In the measurement of resistance R, how much absolute error is present. Delta X. In the measurement of quantity X, how much absolute error is present. That is the meaning. Delta A means absolute error or static error. Absolute error in the measurement of quantity A. In the measurement of quantity A. Quantity A. In the measurement of quantity A. Now, this error may be positive or negative based on the measured value and true value. We can define it may be positive error or it may be a negative error. That means if AM greater than AT, measured value is greater than the true value. In a particular measurement, if the measured value is greater than the true value, measured value is greater than the true value means then error is positive. Error is positive. If error is positive means correction is negative. Correction must be negative. Correction is negative. If measured value is less than the true value, if measured value is less than the true value in a particular measurement, if measured value is less than the true value, this value is less than this value, error is negative. Error is negative. If error is negative, to make the error is 0, correction should be positive. Correction is positive. That is the meaning. Correction is positive. correction is positive. For example, if measured value equal to 5 volts, let us assume that. True value equal to 4 volts. True value equal to 4 volts. Then error is how much? 5 minus 4, 1 volt. Then what is the correction? To make the error is 0. Correction is minus 1 volt. That's why error is positive, correction is negative. 1 minus 1, 0. Error becomes 0. See this example. Error is negative, correction should be positive. Same example. Let us assume that if measured value equal to 4 volts, true value equal to 5 volts, then what is the error? Error equal to 4 minus 5 minus 1 volt. Then what is the correction? To make the error is 0. What is the correction? Plus 1 volt. That's why if the error is negative, correction should be positive. Then only we can make the error is 0. Okay. This is the fundamental definition. What exactly static error? What exactly absolute error? Static error or absolute error? But you remember here, this static error or absolute error does not have any significance. In the practical analysis, this static error or absolute error does not have any significance. That's why we are defining the another type of error, that is nothing but a relative error. We can define the relative error, or it is also called fractional error. We can define fractional error. Now we'll see what is the analysis of relative error. Then from that relative errors, what is the observations we can make? That concept is important for any competitive point of view. Now we can define, go for another type of error, that is nothing but a relative error analysis. Why you are going for relative error analysis means practically this error does not have any significance. That's why you are going for relative error analysis.